Good afternoon, everyone. We are Team 5. Our team name is DDUR. We are presented with Design Option C, which is design an autonomous or semi-autonomous system to clean windows.
Attached below is the design approach that we took. We wanted to understand the method of washing windows, explore different techniques, shorten condensed process, and life cycle engineering. Below is the different things that we avoided, such as the suction cups, squeegees, Roomba, drones, and pressure washers. Seen here is the conventional 5-step conventional method of cleaning a window. To the right of it, we modified it for our robot, so it made it easier for it to clean.
As seen here, these are the listed constraints set to us by the outline of the event. With those outlines and constraints, and the things we try to avoid, here are some sketches that we developed. We wanted each sketch to have a water tank, a suction fan, and a brush on it. Next, we also have 2 more other sketches that we also wanted to incorporate. With these sketches, what we decided to do was make a decision matrix chart. With this decision matrix chart, we wanted to make each of the criteria based off of the rubric given to us by the event.
Seen here is a building view of what we've developed. Our design is secured to the building via a winch and wire, and we also make use of an emergency arrest wire as an added safety feature. As the design cleans each section of the window, it is moved over manually to continue cleaning the windows. Here, the exterior and the interior of our design is pictured. We made use of a triangular shaped frame to balance the weight distribution and counteract the moment of the winch wire. We incorporated a 60-liter water reservoir and rotating cleaning brush that are located at the base of the structure to ensure optimal cleaning and weight distribution. Our electrical and mechanical components are located above our water source so as to eliminate any possible hazards. We made use of solar panels to supplement our power, fans that are vented directly to the window to aid in sectioning the apparatus nearer to the window, guide wheels, and flashing amber lights as a safety precaution. Proximity sensors are used to tell if the windows are open or closed and to detect when the robot is at the base of the building or on the roof. On this side, the fan column for venting can be seen in the cross-section pictured above. The bumper skirt is also visible, which is another safety measure that we've included. Our design makes use of a soap and water mixture to clean the windows.
For the safety of the frame, we wanted to try a lightweight material, so we decided to use aluminum 6061. And to do this, we also wanted to make a MATLAB simulation to make sure that there wasn't too much bending distributed by the weight of all the components and the water tank. We found out that actually using a 1/8 inch thickness aluminum pipe was more than enough for the deflection.
Some things we put into consideration for safety is that this autonomous window cleaner should not be used when the wind speeds are higher than 40 kilometers per hour. According to working at heights training, workers are not to be working at such high-speed winds. If workers cannot be on the roof setting this up, it is too dangerous to be operating. 2 people must be present at all times. Parts that were added for safety include a thin bumper skirt, single winch cable, backup catch cable, and SIM card application. Here's our robot modeled in NX. Here's the exploded view of all our parts. And here is a cross-section view.
Seen here is our bill of materials. Most of these items can be purchased online at a retailer such as Amazon, and they're actually mostly standardized parts, so therefore it'll be easy to obtain and also to use. Over here we have the cost analysis. On the right is a pie chart with the itemized cost and the approximate percentage of the overall cost. The total cost of materials is $877. The approximate cost to produce, including manufacturing and other expenses, is about $1,877. Our competitor's retail price is at $60,000, and our suggested manufacturer retail price is $50,000. We had this amount based off of the R&D that costed approximately $600,000 per year for a small startup company, which justifies the unit's pricing.
For comparison, what we did as a baseline, how much money it would take for a single crew of men to clean a building with 50 stories tall. At one time building cost, it would cost $20,000 for the team of men to clean. But at the time its second building is cleaned, it would actually be cheaper to start using our product instead.
Here we have the subscription business plan, and it's essentially a monthly subscription and maintenance available for users that can pay at an optional buy-in. We also have a rental service plan for those who don't wish to purchase a product. They can rent at either $225 by the hour or $1,500 by day.
Here we have modifications that could be included to improve our design. The first and foremost important modification that could be made is improving our material quality because it reduces our overall costs and gross weight. Other changes that could be made are modifications to the internal structure to increase modular design and offer training programs as a part of our marketing. These are our references.